So I was telling you guys last week that we're gonna learn more about circles than you ever thought there was. We're doing 8 sections on circles, and so today what we're gonna do is learn some theorems about chords of circles and what happens with their arcs. So we're gonna learn several different theorems as we go through. So just a reminder what a chord is. A chord would be when you draw a circle, okay? A chord would go from one end of the circle to another end of the circle, and it can be a diameter. It doesn't have to be at all, but it could be. So it could be just a tiny little thing up here, as long as it has its endpoints on the circle and you connect them, that's a chord, okay? This first theorem that we're gonna learn is not bad at all, and what it says is if you have in the same circle or in congruent circles, if you have 2 minor arcs that are congruent, so you guys remember from last week, minor arcs were less than 180. So this chord makes a minor arc between F and G right there. This chord makes a minor arc between J and H right there. And what this is saying is if your minor arcs are congruent, your chords are going to be congruent. And it works the other way also. This is an if and only if theorem, and when you have an if and only if theorem, that means if you read it forwards, it works. If you read it backwards, it works. So if the chords are equal, the minor arcs are equal. If the minor arcs are equal, the chords are equal. Okay? So down here, this one is just asking for LM, and notice that these two are both 4. So what would X be? 82. So if your chords are equal, your arcs are equal, so X is 82. Okay? Then, if I look at B, notice here my minor arcs are equal, so that would make the chords equal. So I would just go 2x plus 4 equals 18. And then I would get 2x equals 14, divide by 2, and x is 7. Okay? Then, if I look at this one, if you guys just look at that for a second, can you figure out what you would have to do? Yeah, yeah, you're correct. So these 2 chords are equal, so these 2 arcs are equal, so if that's x, this is x. Now you could do algebra. Devin did this in his head, but if you went x plus 64 equals 360, that would work. Okay, do you guys all know how I knew this was x? Yeah, because if the chords are equal, the arcs are equal. And so say I did the algebra way, okay? 1x plus 1x is 2x. Then you would subtract 64, and you would get that 2x is 296, divide by 2, and x would be 148, I believe. Okay? What Devin said, which is absolutely accurate, is you could have taken 360 and subtracted 64, which would be 296, and then you could have divided this by 2 because the rest of this would be 296, and you have 2 pieces that are equal to that, so if you divide it by 2, you'd get 148, and that would work too. So whichever one makes more sense to you, use that. So now that rule also works if you have congruent circles. What makes two circles congruent? It's when they have the same radius, so they'd be the same size, okay? This tells us these circles are congruent. So what I would do then is if this minor arc equals this minor arc here, that would tell me that these two chords are equal. So I could just say 6x equals 2x plus 24. And then I only have the 24 on the right, no number on the left, so that means I'm gonna bring my 2x over to the left. And then I would have 4x equals 24, divide by 4, and x is 6. Okay. Now let's look here. We have two circles that are congruent again, and this one is a little bit deceiving. What do you think we would have to use in this, Christian?
Yeah, it would be algebra again, because it would be 3x is equal to 9x minus 78.
Yep.
It's kind of tricky with the degrees, but 198 and 62 are equal to 60.
Yeah. So here's the deal. On this circle, instead of marking the degrees for the smaller minor arc, they marked it for the bigger major arc. So if this is 198, this arc would be 360 minus 198, which is 162. So what that tells us then is these two arcs are equal, which would make these two chords equal. So 9x minus 78 would equal 3x, okay? Now, when we do this, I only have the one number on the left, so I'm gonna bring my 9x over, and I get negative 78 equals negative 6x, and then x would equal 13, I believe. Okay. All right, now if we look at this one, this is using something that we learned last week. Do you guys remember learning that central angles equal their minor arc that they intercept? So if this is x, that means this is x, okay? Then notice that these two chords are equal. That would make these two arcs equal. So x would just equal 67. Okay? All right, now let's go to this one. So now we're gonna learn another theorem that's true. And like I said, today we have several theorems that we're gonna learn about arcs and chords of a circle. So when you look at this, this is what this theorem is saying. If you have a circle, oh, that's bad. Say this is our chord, and say this is a diameter. So it goes through the center, okay? What this says is if you have either a radius or a diameter that is perpendicular to a chord, it cuts the chord in half and it cuts this arc in half, okay? So they could say today, this is 12, what's this? They could say this whole thing is 100 degrees and ask what each of those are, okay? So it works if you have a radius or a diameter. If it's perpendicular to a chord, it cuts the chord in half and the arc in half. So, same thing here, diameter, perpendicular, it's gonna make these two parts of the chord equal and those two parts of the minor arc equal. Now, I gave you guys a cheat sheet last Wednesday, or Friday maybe, Thursday. And I believe this right here is on it. This, in my opinion, is the part of today's lesson that's the hardest, okay? So there's gonna be times that they tell you that they have a radius of a circle, and they will ask you to find either this distance right here, or they'd ask you to find this distance, okay? Now, here's the deal. When they give you a radius for these problems, you put the radius right here. The radius would also be this whole distance if I connected from this point to this point. The radius would be that whole distance too. But for these problems, I put the radius as the hypotenuse of this right triangle. They will call the distance from the center to your chord. Do you know what this means? Perpendicular, right? Perpendicular distance from the center. That's this distance. It goes from the center perpendicular to the chord. And I already talked about the fact that these two pieces of the chord would always be equal. And then this would be half of the chord. So that they might say, you have a chord 24 inches long, find, they might give you the radius, and they might give you that the chord is 24 inches long, and they might ask you for this distance here. So if I knew the radius and half of the chord, how could I find that? Pythagorean theorem. So you're gonna do that today. And like I said, I think those are the toughest questions. So this one here is not too bad at all. This says that, remember from Friday we talked about major arcs or minor arcs could be labeled with 3 letters. So this is saying arc DEF is 150. Find DE. What do you think? Do you see how this radius is perpendicular to the chord? That means it cuts this in half as well as that arc in half. So if you have a radius or a diameter perpendicular to a chord, it cuts the chord in half and that arc in half. So if it's 150, these would each be 75. So the measure of DE, which is just this distance here, would be 75 degrees. Everybody understand that one? Okay, now let's go here. These are where they get a little bit harder. This first one's not bad. So here what I have is a radius, perpendicular, like you have to realize if it's right there, it's right here too. So that radius is perpendicular to this chord. Remember that means these two pieces are equal as well as those two pieces are equal, okay? Now in this problem, they tell us that we have a radius of 13. This is super important. Do not write the 13, even though this is a radius, I agree, it is. We don't write it there because what we're worried about here is this right triangle, okay? This distance is not the whole radius. We put the radius right here, okay, as the hypotenuse. Then it says radius OB is perpendicular to a chord, and that whole thing is 24. So what would that tell us about each of these pieces? 12. Okay? So this is 12, and that's 12. Okay? The first question that they're asking us here is if the measure of arc CD, when there's 2 letters, that means it's minor. So it'd be the shortest distance between C and D is 134. Find arc CB right here. Wouldn't you just divide it by 2? And 134 divided by 2 would give us what, 67? Is that right? Okay. So this is 67. That one's not bad. The next one is where we're going to have to use Pythagorean theorem, because what they're asking us here is they're asking us for O to X, which is right here. Again, we're using that green right triangle. You have a cheat sheet for this chapter that has the Pythagorean triples on it. Is this a Pythagorean triple? See that one more time? It's 5, right? 5, 13, and 12. So if you realize that, you wouldn't even have to do Pythagorean theorem. Your answer would just be 5. Okay? If you didn't know that, then you would have to do Pythagorean theorem. If it wasn't a Pythagorean triple, or if you didn't realize it was a Pythagorean theorem. Triple, sorry. Okay, let's go back here. Now this one says the diameter is 12. If your diameter is 12, what is the radius? 6, okay? Then it says CD, which is this whole chord, is 8. So what would each of these pieces be? 4. Okay? Then it tells us that the arc from C to D here is 90. And wouldn't these two pieces be equal from what we learned today? Because the diameter is perpendicular to the chord. So if this is 90, each of these is 45. Okay? Then it says find each measure. And the first one asks us for arc DE right over here, which we just said is 45. Then they ask us for FD, which is this distance right here. Just from F to D, we said is 4. Now, they're asking us for AF, okay? Bless you. What I'm gonna do is make this right triangle. I know that this is 4. I'm looking for this. How do I know what the distance from A to C is? It's the radius, which is 6, okay? So I have this right triangle that looks like this. This is X, this is 4, this is 6, and I have to do Pythagorean theorem there because 4 and 6 is not going to form a right triangle, okay? So if I do A squared plus B squared equals C squared, this is my C. A and B don't matter. I'm going to call this A and this B. So I'm going to go X squared plus 4 squared equals 6 squared. So this would be X squared plus 16 equals 36. Subtract 16. And I get that X squared equals 20. Okay, then I'm going to take the square root, and the square root of 20, if you do that on your calculator,
4.47.
okay. If you saw for this one that they say 2 root 5, have I talked about that?
Yeah.
Like this could be written as 4 times 5, and the square root of 4 is 2, so that would work too. So 4.47 or 2 root 5. Either one is fine with me. Okay. Now let's look here. It says in circle P, the radius is 13. Our RS is 24. So if RS is 24, what would each of these be? 12. Okay. Then it says find each measure, and one of them asks for RT. So wouldn't RT just be the 12 that I just wrote? And then they ask for PT, which is this little distance right there, okay? And so to do that, I'm gonna form that right triangle. If that's a 90, this is a 90. PT is this very little length right here, okay? And if don't I know the radius from right here? So the radius here would be 13. Now, is that a right triangle again? What is it? What, 12, 13? 5. So wouldn't this just be 5? Do you guys get that? 5, 12, 13 is a right triangle. So having that cheat sheet out might help you out. Now let's look at this one. It says AB, which is the segment. Make sure you realize this would be the chord length. This would be the arc length out here. So if the chord length is 60, that means each of these are 30. They tell us that just from A to C is 71. So what would B to C be? 71 also, yes. These two are always going to be equal if your radius is perpendicular to the chord. So the first question asks us for BC, which we just said is 71. Then AD is this distance, which is 30. YD we have to find, and that we're going to find using one of these right triangles, okay? Now, that's 30. The radius is 34, so that's here, and I need to find that. That is one of your Pythagorean triples again. What is it? 16. So having that Pythagorean triple sheet out will help you. So YD is 16. Then it asks us for arc AB. That is this whole arc. What would that be? 142. Yep, 71 plus 71 is 142. BD we have right here as 30. And DC. Okay, this same exact question I believe is on your next quiz. And I always get this, I might have changed the numbers a little bit, but kids always get this wrong. We want this distance right here. I know due to this, no, did I find YD? Yes, YD is 16. Oops, had I already wrote that? Sorry. Okay, so this right here is 16, okay? That's 30. Here's what kids will tell me on the test. They'll say, if this is 16, this is 16. That is not true. Do you guys get that this is a radius and it's 34? And isn't this a radius? So it would be 34. So if this is 16, wouldn't this be 34 minus 16? And 34 minus 16 is 18. So this little thing right there is 18. It's not 16. Do you guys all understand why? Okay, so that is 18. So try to remember that for your next quiz. Last question, or last theorem I should say. This one is not as hard as that previous one. So there is something called a perpendicular distance from the center for a chord. So if you have a chord and you draw a segment from the center to that chord that is perpendicular, and then you have another chord and you draw a segment from the center to that chord that is perpendicular, what this says is if those lengths are the same distance, these two chords are going to be equal. So if the two chords are the same perpendicular distance from the center, if these are the same, the chords are going to be the same. And then it's an if and only if, which means it works both ways. So if the chords are equal, their distances from the center are going to be equal. Okay? So if we look at this first one, notice that the two distances from the center is 9. Okay? What that tells us then is these two chords are equal. So I would just go 7x minus 20 equals 3x. Now I'm going to bring that 7x over by subtracting it. And I get that negative 20 is negative 4x. Divide by negative 4. And x is 5. Okay? Then that is our x, so that is our answer. This one says chord JL is congruent to chord LN. When those two chords are the same, the perpendicular distance from the centers are going to be the same. The chords are equal, their distances from the center are going to be equal. And they tell us that Kn, this distance right here, is 3x minus 2. And Kp, which is this one, is 2x plus 1. So if the chords are equal, these two distances are equal. So we would just set those two equal to each other. So I'm going to subtract 2x. Okay, 3x minus 2x is x, minus 2 equals 1. Then I'm going to add 2, and x is 3. All right. Then, if I look at this one, it says in circle P, EF, which is this chord, equals GH, which is this chord. That means these two distances are going to be the same. Okay? And they tell us that chord EF is 24. I don't think we need this. And chord GH is 24. I don't think we need that. So because those chords are equal, their distances are the same. So first we're going to set these equal, and this one is just one step different because once we find x, we have to put it back into PQ. So I'm going to bring my x over. 4x minus 2x is 2x, minus 3 equals 3, and then I'm going to add 3. So I get 2x is 6, then I'm going to divide by 2, and x is 3. And then I just have to take this one step further, and I have to find PQ. Well, PQ is this, 4x minus 3. So then I take this 3 and put it in there. 4 times 3 is 12 minus 3, which would be 9. Then let's look at this one. Chords AC and DF are equidistant from the center. Now one thing, sometimes our book forgets to do this, but this really is only true if these are perpendicular distances, and sometimes they forget to do those right angles. It says BG and EG, oh, it tells us they're perpendicular. If the radius of circle G is 26, what that tells us is this is 26 if I look at this triangle, or this is 26, okay? And the first thing they want us to do is find AC, which is this whole chord, okay? So what I'm gonna do is I'm gonna use this right triangle right there. And in that right triangle, I know one side is 10, one side is 26, and I'm trying to find X. That's a Pythagorean triple, and it's 24. Okay, so 24, 10, 24, 26 is a Pythagorean triple. So do you guys get it? This is 24, this is 24, and AC would be 24 plus 24, which is 48. Then they ask us for DE, and this is something I actually forgot to tell you guys. So if you're looking at that same circle and you have two chords, it actually works out that these four pieces are all the same, okay? And then I can't really draw it on here, but it also, or that one, I'll show you on another one then. But anyway, those four pieces are the same, so DE would also be 24. Okay. Then, if we look at our last question, I can explain this on this one. So, if you have two chords that are the same distance from the center, what that would tell us then is these four pieces are actually equal, and this arc XB would be equal to XA, which would be equal to CY, which would be equal to YD. So all four of those pieces of those arcs are also equal. So what they tell us here is CD is 24. If CD is 24, what are each of these two, CR and RD? 12. And do you get, these would be 12s also? Okay. Then the other thing they tell us is arc CY is 45.
Except for AD. AD is 24.
Say that again.
AD is 24, not 12.
I'm saying this little thing is 12 and that's 12.
Ah.
Okay?
Yes, I'm sorry, I was thought you talked about the questions.
Yeah, no problem. This is 45, so this is 45, so this is 45, as well as this is 45. So now if I go to put these in, AQ is this little piece, which is 12. RC is this piece, which is 12. QB is this little piece, which is 12. AB is the whole thing, which is 12 plus 12. DY, and that's the measure of the arc DY out here, is 45. And then, let's see what else they ask. AB, what would AB be? 90. 45 plus 45 is 90. And AX is 45. XB is that arc 45. CD is this whole thing, which again is 90. And that's it. Did you guys think it was hard today? Okay, I need to link this super quick, so give me 1 second to do that. It's a worksheet, and I have to really quick link the snapshot. So it's week 8, but when you go in there right now, it's not going to be there, so I'm going to do it super